Assalamualaikum and hi semua. Today I want to discuss the chapter 3, which is momentum and impulse. So this is the overview of the chapter 3, momentum and impulse. We have a linear momentum, impulse, conservation of momentum. Under the conservation of momentum, we have a collision, and we have two types of the collision, elastic and inelastic collision. Okay, so we go for our learning outcome. The first learning outcome is momentum and impulse. So define momentum and impulse, which is J equal to F delta T, and then solve problem related to impulse and impulse momentum theorem, which is J equal to delta P equal to mv final minus mv initial, and then use FT graph to determine impulse. So we go for the first learning outcome is define momentum. What is momentum? Momentum is the product between mass and velocity, and is a vector quantity. So the equation is P equal to mv, and the unit is kg, meter per second. The direction of momentum is the same as the direction of velocity. Okay, let's say we have momentum to this direction. Okay, and then we know that the momentum is a vector quantity. So it means that we must resolve this momentum to the x component, which is we label it as momentum of the x component, and then momentum of the y component we label it as py. So the px, like I already teach before this, the theta is to the x-axis, so the x-axis will use cos, means that the px equal to p cos theta, and we know that the momentum p is equal to mv, so which is become mv cos theta. And then if the x component use cos theta, so the y component will use sin theta. So the py become p sin theta, and the p is mv, so become mv sin theta. Next we continue with the impulse, and we use the symbol of impulse is J. So what is the impulse? Impulse is the product of a force and the time t. Or we can write down by using the equation J is equal to Ft, and J is impulse, T is time, and F is impulsive force. The impulse is a vector quantity, and the direction same as the constant force on the object. And unit of the impulse is Newton second, or we can write down kg meter per second. Force is a non-constant force. So let's say we have the J equal to integrate T1 until T2 and F dt, so it become F average times with T. So the average force is the average impulsive force. Next is impulse momentum theorem. For a single constant force F act on an object in a short time interval, which is sum of F equal to F equal to rate of change of momentum equal to constant. So from this equation, we rearrange this equation, it becomes F delta t equal to dp. So this is equal to the impulse J. Okay, and the dp here means final momentum minus with initial momentum. So this is equivalent to J impulse, means that in another equation of impulse we can use F times with delta T. So the impulse momentum theorem state that the impulse of a body equals to the change of the body momentum. We already learned just now, which is J is equal to F delta T equal to change in momentum, which is change in momentum means that P final minus with P initial, and the momentum, we know that momentum is equal to mv, means that mv minus mu. Because the same mass here, we can factors this equation become mv minus u. Okay, if we need to separate the equation by its components, so the j become jx equal to f average of the x component times with t, so equal to p2x minus p1x and mvx minus ux. And if you want to resolve to y components, so jy equal to f average of the y components times with t, so it becomes p2y minus p1y and equal to mvy minus uy. So we are discuss about the 2D collision only. Okay, next learning outcome is we want to use the ft graph to determine the impulse. Okay, let's say we are given the graph of f against t graph. So the shaded area under the ft graph is equal to the impulse J. We discuss about example 3.1. A 0.2 kilogram tennis ball strikes the wall horizontally with a speed of 100 meters per second, and it bounces off with a speed of 70 meters per second in the opposite direction. Okay, so before we start to solve the problem A and B, we sketch a diagram first. So let's say this is the wall. Okay, and then the u, let's say we put it to the right, u equal to positive 100 meter per second. And in the question, tell us that it bounced off with a speed of 70 meter per second in the opposite direction. Okay, because it bounced off with the opposite direction, so v here we must put it negative 70 meter per second. So we solve for the first problem A. Now calculate the magnitude of impulse delivered. Magnitude of the impulse delivered means that the question asks you the positive value only. So we start this solution by using the equation of J equal to change in momentum. So which is change in momentum P final minus with P initial. So equal to mv minus u. So J equal to m v minus u. So equal to the mass just now is 0.2. V we must put negative because of the opposite direction. So negative 70. Minus u is to the right. We take it as positive. So it becomes negative 34 Newton second. But the question asks you the magnitude, so you must put the positive value of the impulse only. So it becomes J equal to 34 Newton second. Next question. If the ball is in contact with the wall for the 10 millisecond, determine the magnitude of the average force. Magnitude means that the question asks you the positive value only. Okay, means that to solve this problem, we will use the positive value of J, which is J is equal to positive 34 Newton second. So by using the equation of J equal to F average dt, so 34 here, F average, the dt 10 times 10 power of negative 3. So average magnitude of the average value is 3400 Newton. Next example is 3.2. We are given with the graph of F against T, and please be careful here, the force is in unit kilo, which is times 10 to the power of 3, and the time taken given in unit milli, so it becomes times 10 to the power of negative 3. Okay, an estimated force time curve for a tennis ball of mass 60 gram struck by a racket and shown in figure 3.2. Determine the impulse delivered to the ball and the speed of the ball after being struck, assuming the ball is being served, so it is nearly at rest initially. So u initial speed is equal to 0. So first of all, we are given m is equal to, we must convert to kilogram. So 60 times 10 to the power of negative 3 kilogram. So from the graph of F against T, we must know that from the graph of M against T, we will get the impulse. And the impulse is area under the graph. Area under the graph of FT graph. Okay, means that here equal to half 1.8 minus 0.2 times 10 power of negative 3, and then times with 80 times 10 power of 3. So become impulse equal to 14.4 Newton second. Okay, next one. To solve a problem, to determine the speed of the ball after being struck. And initially, the initial velocity u is equal to 0. Now we are using the equation of J equal to delta P, so equal to mv final minus u initial. So we substitute here, the impulse just now is 14.4, so equal to, and the mass is 60 times 10 power of negative 3, and v we want to determine, and initially at rest, so 0. So we get the velocity is 240 meter per second.